All right, let's put integration in context. So suppose a gauge at the outflow of a reservoir measures the rate of water in cubic feet per hour. So here's the outflow, and this is in cubic feet per hour. And then we keep track of that rate of water flow for 8 hours. So that's the time here. So this is time in hours. Find the amount of water that flows out of the reservoir during the first 4 hours. So let's label that in pink. And let's go ahead and find the number 4. That's here. And I'm going to just label the amount I'm looking for. So the area under this curve that represents the rate of flow of water out is going to give us the total water that has flowed out of the reservoir. So what we're looking for is the integral from 0 to 4, and I haven't named this, and this is a reservoir, so I'm just going to call this r of x. So the integral from 0 to 4 of r of x dx. Well, this is a triangle, so we can easily figure this out using geometry. So we have 1/2 our base of 4 hours times our height of, what is this, 10, 20, 30, 40,000 cubic feet. 40,000 feet cubed per hour. So now multiplying that together, we end up with 80,000 feet cubed. So during the first 4 hours, I almost wrote 8,000, 80,000 cubic feet of water have flown out of the reservoir. It has escaped the reservoir, however you want to write this. Has flowed. There we go. All right, let's continue to part B. Find the amount of water that flows out of the reservoir between 4 and 6 hours. So between 4 and 6 hours, and I'll go ahead and label this in green. So here's 4 and here's 6. So I'm looking for the area of this region. Well, this can also be done geometrically. And if you notice, this is a nice slicing in half here. So we want the area from 4 to 6, r of x dx. And we can write this, I guess we can write this as a triangle, or we can just count squares. So I'm going to break up all these regions. So this is region 1, this is region 2, and here this larger part is region 3. Let's start with region 1. Region 1 is 1/2, and the base is 1 hour. And what's the height is this value up here, that represents 10,000 cubic feet. And that's per hour. Plus we have 1 hour times, again, 10,000 cubic feet per hour. And then plus this larger region, which we have 2 hours at the base, times, what is that, 40,000 cubic feet here. All right, so multiplying all that together, we should get 5,000 plus 10,000 plus 80,000. So we should get 95,000. There we are. That's what I get for trying to do arithmetic in my head. So we get 95,000 feet cubed has flowed out between 4 and 6 hours. All right, so let's keep going. Okay, so as you can see, I went ahead and redid my screen here so you could see parts C and D, but on your paper, they're still going to be on one page. So for part C, does more water flow out of the reservoir during the first 4 hours or between 4 and 6 hours? So if you recall, during the first 4 hours, so the integral from 0 to 4 r of x dx was equal to 80,000 feet cubed. And the integral from 4 to 6, f of x dx, was equal to 95,000 feet cubed. Clearly this number is larger, so more water flowed out or between 4 and 6 hours. Okay, so for part B, what is the total amount of water that has flowed out of the reservoir during the 8 documented hours? Well, we already know that 80,000 feet cubed poured out during this time. And then we know that 95,000 feet cubed poured out here. So we just need to figure out the area of this region. So we want the area from 0 to 8, r of x, and that shows that I wrote this as f of x here when I meant an r. So r of x dx is equal to the integral from 0 to 4 r of x dx plus the integral from 4 to 6 r of x dx plus the integral from 6 to 8 r of x dx. And I'm going to compute this last one up here. So this last one, I'm going to compute it here. So the integral from 6 to 8 r of x dx is equal to, and that's this region, and again I'm using pink, and the base is 2 hours. My height represents 50,000, and I keep wanting to say gallons, but they wrote this as feet cubed per hour, so I'll leave it that way. So 50,000 feet cubed per hour. So that becomes 100,000 feet cubed. So let's put this all together. We have 80,000 plus 95,000 plus 100,000. And if I'm doing this correct in my head, I think you get like 275,000, but I'm going to quickly use a calculator just to double check. Yep, 275,000. So between 0 hours and 8 hours, 275,000 feet cubed poured out of the reservoir.